This video is for class 6 mathematics, and in this video we are learning about term from the chapter Fundamental Concepts of Algebra, right? A term is a constant. It might be a constant, a variable, a product, or a quotient of constants and variables, right? So let me try to explain this. When we were doing exercise 18a, we learned how to write algebraic format. For example, you might have written 4 plus x equals to 15, right? 4 plus x equals to 15. So when we were writing algebraic format, we were using this particular numbers, alphabet, right? The signs, etc. So now each of this number or alphabet, right, are called terms, right? Are called terms. So now 4 is a term, right? X can also be a term. 4x, if there is anything, any algebraic expression, anywhere we are using 4x, then 4x also becomes a term. 3 upon y is a term, which is the quotient of the constant and variable, whereas this is the product of the constant and variable. So term is called a constant term if it does not contain any literal variable. That means like here 3, 20, 517, minus 4 upon 9, they don't have any alphabets along with them, so they are known as constant term, right? Whereas those which have variables with them, right, they are known as variable terms. Okay, fine. So I hope you understood what term is, right? Collection of terms, right, will create one algebraic format. Okay, the collection of terms will create one algebraic format. Now going to the next portion, constants, okay, fixed numbers and variables, literal numbers like a, b, c, d, etc., may be combined to form several types of terms. For example, the constant 2, 5, minus 8, 4, 3 upon 2, etc., and the variables x, y, z, etc., may be combined to form terms such as 2x, 5y, 5xy, 5xyz, 4xz, 3 upon 2 yz. So here each one of them are single term. Now there are two kinds of terms. Okay, Number one, okay, going to number one, we have like terms. Now what are like terms? The terms having same literal coefficient, same alphabet, are called like terms. They may differ only in their numerical coefficient. That means number can be anything, but the alphabets needs to be same. Like for example here, xy, 5xy, minus 4xy, etc., are all like terms. Why? Because here what you can see is all of them have xy. Here just below that example, that is example number 2. Now what you can see is minus 8x square y, 7x square y, 1.5x square y. So here these three are all like terms. Although they have different numbers in front of them, right? Although they have different constants in front of them. Fine, did you understand till here? So now what are like terms? Like terms are those terms who are having same literal coefficient. That means same alphabets. Now you can ask me a question. In both of these two examples, both have xy. This also has xy, this also has xy. So can they be like term? Is xy and 8x square y minus 8x square y are like terms? No, they are not like terms. Although they have same x and y together, this also has x and y, but there's a square, but there's a power with the x, which means x into x. So then it will not match. It needs to have xy. It needs to have xy, right? Or suppose, right, suppose we have one example, 8xy, right, and there is another number like 7 yx. Are they like terms? Yes, they are like terms. Yes, they are like terms. Why? Because both of them have x and y. The sequence does not matter. The sequence does not matter, right? I hope you are understanding like terms. Okay, but if I put a square here and if I put a square with y here, will they become like terms? No, then they will not become like terms. They are not like terms. I hope you understood like terms. Now those who are not like terms, they become unlike terms. Very simple, right? Unlike terms. The terms that do not have same literal coefficients are called unlike terms. For example, these two here are unlike terms. Okay, this and this here are unlike terms. This and this are unlike terms. Okay, for example, 6a, 6ab, 6ac are unlike terms. 2xy, 2x square y, 2xy square, they are also unlike terms, although they have same number in front of them, that is 6, 6 and 6. It does not matter. Okay, what matters is the literal coefficient, the alphabets. Okay, in the second example also you can see they have 2, 2 and 2 here, but still they are unlike terms because their literal coefficients are different. I hope you understood like terms and unlike terms, and with the help of this knowledge we can go to exercise 18b and try to do some questions. So coming to exercise 18b number 2, group the like terms together. So in the first question, the question given to us is 4x minus 3y minus x 2 upon 3x 4 upon 5y and y. So we have total 6 terms, right? And out of these 6 terms we have to group the like terms together. Okay, here if you can see, there might be 2 groups possible, a group of x and the group of y's. Okay, so what is the first group of like terms? 4x minus x and 2 upon 3x, right? So first group will have, okay, let me write it. So the first group will be, this is number 2 1. Okay, the first group will be 4x comma minus x, and if there is no space I need to use a comma here, you can write and 2 upon 3 x. The next group will be minus 3y, second group. Okay, second group will be minus 3y comma then next one is 4 upon 5y, right, and y. Okay, I hope you understood how to do this. Okay, please try to do the other sums as well from number 2, grouping the like terms. Those who are there in the Google Meet, we have already done this also, right? Try to do number 2, try to do number 3 and try to do number 4. Okay, thank you so much. This is all for this video.